Let's take a look under the bonnet. To the right, we can see the 12-volt fuse box, 12-volt battery, and to the left, a pair of coolant reservoirs. One is for the high voltage battery, capacity at 4 liters. The other is for high voltage components such as the traction motor, inverter, and CCU. This reservoir has a capacity of 5.6 liters. Furthermore, in front of the high voltage component reservoir, there is a washer fluid reservoir. The washer fluid capacity is 2.5 liters. Have you noticed the new addition under the bonnet yet? The MSD plug is now located in front of the 12-volt battery for easier access when the vehicle is in service. Please refer to the service guide to safely remove the MSD. HVAC. The heating and ventilating air conditioning unit is located under the bonnet too. There is a service door to access the cabin filter. To the left of the HVAC unit, we can see the high and low pressure service valves. MG4 is now equipped with IBS, Integrated Braking System, mainly consisting of the following components: pedal assembly in the driver's footwell, sealed master cylinder, booster assembly integrated with the stability control system function, valve block, IBS control unit, brake fluid level sensor, brake fluid reservoir. Compared with previous systems, IBS is a vacuum-free braking system. Brake fluid type is DOT4 with a capacity of 800 milliliters. Please refer to the braking system work booklet for further details. Situated on the right chassis leg, we can see the chiller. The EXV valve controls the quantity of refrigerant flowing into the chiller to rapidly cool coolant, reducing the high voltage battery temperature where required under heavy loads or during rapid charging. Comparing with traditional thermostatic expansion valves, the EXV has a wider adjustment range, more accurate, and faster. If we follow the right chassis leg under the coolant reservoirs, we can see the thermostatic expansion valve, also known as TXV. The refrigerant flows from the metering valve to the evaporator. The metering valve reduces the pressure and temperature of the refrigerant, changing the solid stream of refrigerant into a fine spray, improving the evaporation effect. As refrigerant passes through the evaporator, it absorbs heat from the ambient air flowing through the evaporator core. The increase of temperature causes the refrigerant to vaporize and increase in pressure. The temperature and pressure of the refrigerant from the evaporator drive the diaphragm and the temperature tube to regulate the metering valve opening, thereby controlling the volume of the refrigerant flowing through the evaporator. The warmer the air flowing through the evaporator core, the more heat available to evaporate refrigerant. This allows more refrigerant to pass through the metering valve. Please refer to the AC system work booklet for further details. Here is a view under the front subframe assembly. The front suspension is a traditional McPherson and strut setup. We can see the auxiliary components attached to the rear of the subframe. ESS PTC heater, HVAC compressor, also referred to as the electrical air conditioning compressor, EACC, and the high voltage component coolant pump. The compressor is the pump of the refrigerant circulation. The compressor compresses the low pressure vapor from the evaporator and converts it into the high pressure refrigerant at the condenser. The compressor compresses the AC system with the required amount of refrigerant by changing the speed of the high voltage motor. To the left, we can see the EPS. So let's see what's new here. New to the MG4 is the dual pinion electric power steering. This is where the motor is attached to the steering rack, assisting via its own pinion. This system is controlled via chassis CAN bus. Please refer to the steering work booklet for more details. On the left side of the subassembly, we can see the PTC heater for the high voltage battery. PTC stands for positive temperature coefficient. There is an inlet and outlet for coolant to pass through the heating element within. The function of the PTC heater is the opposite to the chiller. There is a low voltage connector on the north side of the ESS PTC heater. Located behind the center console, the AC PTC heater heats air to meet the requested target temperature from the customer. The AC controller controls the on-off function in the electric heater and the target temperature according to the settings on the AC interface. The high voltage electric heater features a low voltage connector and a high voltage supply, B+ and B-. The cooling system is divided into two separate systems. One is for the high voltage battery, and the other is for the high voltage components. The cooling system utilizes the principle of heat conduction. Coolant is circulated in the individual cooling systems to keep the combined charging unit, traction motor, and high voltage battery at optimum operating temperature. There is one pump per circuit. Both are located on the right side of the vehicle. One is located on the subframe, and the other is attached to the right chassis leg between the chiller and the TXV. Please refer to the cooling system workbooklet for further details. The ESS. The energy storage system is also referred to as the high voltage battery. There are two types, 51 kilowatt and 64 kilowatt. The battery management unit, BMU, is now located to the rear of the battery. The ESS contains 104 battery cells without individual modules. They are placed in 3 rows, 36 cells stacked within the outer rows and 32 stacked in the center row. Each row is monitored by the CMU inside the ESS. They are situated in front of the BMU. The cells are non-replaceable. Please refer to the high voltage workbooklet for further details. The charge port is fitted at the rear of the vehicle. The charge port contains two types of interfaces, AC and DC. Press the door in this area to open the charge port door. Once the charge port door is open, we can see a label with the letters C and K. Let's take a closer look. The labels refer to a charging type standard introduced by the European Union to help owners find the correct charging station. C refers to what is called the Type 2 connector. K refers to the Type 3, or more commonly known as CCS, combined charging system. There is a charge door latch, which also has a manual release. There is also a charge port drain for when the charge door is open while charging. Let's have a look behind the charge port. Firstly, the charge port drain. We also have a high voltage DC cables going through the PDU, power distribution unit, and then to the high voltage battery, or the ESS. Earth point, high voltage AC charge cables. This line goes to the CCU, combined charging unit, emergency release cable, low voltage connector. The emergency release for the charge door is located on the left side of the boot. Simply remove the small trim and pull the cable through the service hole. Here is what it looks like behind the trim. Also, the EVCC is located above the wheel arch, behind this trim. It communicates with the charge port to control AC and DC charging. The combined charging unit is connected to the PDU, power distribution unit, and charge port. HVAC is converted into HVDC and low voltage DC, charging the ESS and 12-volt battery. Under driving conditions, the CCU can convert the DC current from the ESS into low voltage DC to power the vehicle or charge the 12-volt battery. Here is the left side of the CCU. We have a high voltage AC cable connecting the charge port. There is a high voltage DC line to the PDU, low voltage connector via CAN bus, 12-volt battery cable. Now let's have a look at the right side of the CCU. Earth, coolant inlet, coolant outlet to the IMCU, also known as the inverter. The high voltage power distribution unit, PDU, is located at the rear of the vehicle. Its main function is to distribute the electrical energy from the high voltage battery pack, pass through the PDU to the PTC heater, high voltage AC compressor, ESS PTC heater, and the IMCU. Using an AC charger, voltage passes through the CCU, PDU, and then to the BMU. When using DC rapid charge, voltage is passed through the PDU directly into the ESS. The BMS and the EDM have been integrated into what is called now the BMU. However, in the workshop manual, it is referred to as the EDM. Battery Management System, BMS. The BMS evaluates the status of the battery pack based on the information collected, such as voltage, temperature, and bus current. It also calculates the remaining battery level, remaining mileage, and the life status of the battery pack in real time. Furthermore, it manages the on and off board charging and provides the battery pack with information for the vehicle. Electrical Distribution Module, EDM. The EDM controls the output of all high voltage circuits in the battery pack through B+ and B- and pre-charge relays. This dedicated electric vehicle platform adopts a 5-link independent rear suspension system, saving space and enhancing driving response, stability, and increase in comfort. Rear camber is adjustable as well as rear tow. Always refer to the workshop manual for post-calibrations after carrying out a wheel alignment. Now let's have a look at the EDU. EDU. The electronic drive unit is a combination of 3 components: TM, traction motor, differential, and the IMCU, intelligent motor control. The 3-phase traction motor is a permanent magnet synchronous motor, where the rotor and the stator move in unison. This motor is controlled by the IMCU. There are 4 energy recovery modes: low, standard, high, and auto mode. In auto mode, intensity is based on the road conditions and the distance to the vehicle ahead. The IMCU is an electrical control unit that controls the drive motor. It communicates with the IPK and BCM and other controllers via high-speed CAN. It is also one of the anti-theft modules. Being the inverter for the traction motor, when the vehicle is being driven, the IMCU converts DC from the HV battery to AC for the drive motor. When the vehicle is in regeneration mode, the IMCU will convert AC to DC. Let's have a look at the park gear mechanism. EPMCU. The electronic park motor control unit houses the control module, park motor, and sensors. This module is fitted to the left housing of the inverter using 4 bolts. The inverter can be also referred to as the reducer. The spline at the end of the park motor is connected to the park shaft gear on the park mechanism assembly, which is located in the traction motor. When this module receives the park gear signal, the park motor operates, drives the park mechanism, and locks the park gear on the output shaft to lock the electrical drive unit. There is an emergency release port machined in through the EDU torque reaction arm. Behind the mount sits the EP MCU. Remove the dust cover. There is a 5-sided head special tool required. TPT 00312. Insert and rotate clockwise to unlock the traction motor. Located at the top of the control module, there is a low voltage connector. Please refer to the brake system workbook for more information. This concludes part 2 of the MG4 product introduction.